Well, hello there. Now that we know a little bit about the hyperbolic functions, it's useful to know the derivatives of the hyperbolic functions, and I want to derive the first two together, and then I will give you the rest of them in a table. So let's start with hyperbolic sine of x. So let's find the derivative of hyperbolic sine of x. Now, to do that, we have to differentiate the formula for hyperbolic sine that we were given, which is e to the x minus e to the negative x all over 2. And we don't have to use the quotient rule here, right? We're not dividing by a whole function. We're just dividing by a constant. So really, we can just differentiate the numerator and put it all over 2. This is really the derivative of e to the x minus e to the negative x all over 2. And we can differentiate those fairly easily. The derivative of e to the x is just e to the x minus, now for e to the negative x, we have to use the chain rule because this is a composition of functions. The derivative of the outer function, e to the u, is just e to the u. So that's going to be e to the negative x. But then we have to multiply that by the derivative of the inner function. And the derivative of negative x is going to be negative 1 all over 2. And what this negative 1 does is it changes this term from a negative to a positive because these two negatives cancel each other out. And so we end up with e to the x plus e to the negative x over 2, which hopefully you recognize as hyperbolic cosine of x. So the derivative of hyperbolic sine is hyperbolic cosine. All right, let's do the same thing, but with hyperbolic cosine, d over dx of cosh x. Again, we're going to write this in terms of the formula for the hyperbolic cosine. That's going to be e to the x plus e to the negative x over 2. Now, we could go through and do all of those steps that we did before, but I want to point out the only difference between these two functions is that the second term here is positive, where it was negative before. So when we go through and differentiate these, everything is going to be the same, except that second term, we're going to have to take the opposite of what we had before. Now, when we go through and differentiate this, we ended up with, actually, I'm just going to draw this little arrow. When we differentiated this top part, we had e to the x plus e to the negative x over 2. But if we change the sign of the second term in the expression that we're differentiating, that's going to change the sign in the second term of the answer. And so instead of a plus, this is going to end up being a minus. And we recognize this as hyperbolic sine of x. So the derivative of hyperbolic sine was hyperbolic cosine, and the derivative of hyperbolic cosine is hyperbolic sine. Now, we could go through these one at a time and find the formulas for the derivatives of the other 4 hyperbolic functions, but I don't want to take the time to go through and do all of that. Honestly, for me, just having students learn a little bit about these functions and see what the derivatives are and do a few problems, that's enough for me for a family of functions that you may have never seen before this class. So I'm just going to give you the table of the derivatives, and then there will be a few videos of example problems if you want to work through a few of those to get your feet a little dirty with these. But for now, let's look at the derivatives. And here we go. As we already saw, the derivatives of hyperbolic sine and hyperbolic cosine are hyperbolic cosine and hyperbolic sine, respectively. The derivative of hyperbolic tangent is hyperbolic secant squared, looking a little familiar to what we've seen before with trigonometric functions. And then we also have the derivatives for hyperbolic cotangent, secant, and cosecant. The derivative of hyperbolic cotangent is negative hyperbolic cosecant squared. The derivative of hyperbolic secant is negative hyperbolic secant hyperbolic tangent. The derivative of hyperbolic cosecant is negative hyperbolic cosecant times hyperbolic cotangent. And the person who is going through and making the captions for this video surely hates me right now with that long paragraph of intense mathematical vocabulary that we have just laid on them. So let's appreciate the wonderful people who are making the captions for these videos. A little round of applause. All right. That's all I want to talk about for now. Again, there's going to be a few example problems. You can watch those videos, work those problems out to get a bit of practice. But really, most instructors don't do too much with these. We just want to introduce them so students get a little bit familiar with them.